Today's video is about using an ultrasonic thickness tester to test the thickness of the steel hull plates. I start using this to test the thickness. I'm going to go down to my most suspect areas and start cleaning them up so we can get as much of the surface corrosion off and get an accurate reading of how much real metal's left. So here we are again. This is the stuffing box, or the stern gland we took apart last week. Now the hull below the stuffing box has been, it had salt water dripping on it the whole time, so it's pretty corroded. So I'm going to get the needle gun onto it first, get the bulk of the thick corrosion off, then we'll get the wire wheel onto it, clean it up, then we'll do our ultrasonic thickness testing on it. I'm going to set the vacuum up and start getting rid of some of this crud so we can see what we're left with. Okay, that's about as much loose stuff as the needle gun's getting off. So now I'm going to get into the wire wheel. I will also brush the underside and then we'll do our thickness testing. So the hull's normally like this, with a bit of shell, a bit of old anti-foul, whatever, and so I've cleaned it up to look like this now. Calibration documents come with it. Then we get the unit itself, which I said this one's the TI-25 LTX, which is specifically for steel only. It's actually really nicely made. I saw online a fair few different models, a lot of kind of cheap plasticky ones, and this one with a metal case made in the US definitely seemed the best I could find, so I'm glad that's the one we've got. Here is the transducer, which we press against the metal, and it just connects to the unit with two plugs, so one's you transmit, one's you receive, doesn't matter which way around they go. Then you get a little bit of the coupling solution. You can't have an air gap between the transducer and the metal, so you put a few drops of the coupling solution onto the metal, then you can press the transducer onto it and know you've got a good connection. It's powered by a couple of AA batteries that live under here. So switch it on. So here you see in the top corner there 5918, which is the velocity for steel 4340, and this isn't adjustable on this unit, but if it was an adjustable unit, Checkline make a huge range of these units, then you need to make sure you've got the right velocity for the material you're measuring. Here we've got a battery level, and then these markers to the left here are saying how often the unit is getting the same reading over and over. So if you get all 6 bars, it means it's getting a very consistent reading, which means you can have a high confidence in that reading. If you're not getting all 6, then maybe you should have a look at what's going on, why you're getting slightly varying readings. And when I say varying readings, I'm talking like multiple times a second, it's sampling. So this is your confidence indicator. Then here, the main display is the thickness you're getting. In this case, I've got it set to millimeters. Also down the bottom here, you'll see it says STL, which is steel. So steel here and your velocity here are telling you the metal you're testing. Alright, first thing I do now is zero the unit. So it's like a sort of calibration process. It's very similar to zeroing some digital vernier calipers, for example. If you don't do that, it's going to be out, consistently out by a set amount. So we're getting that amount that it's out by back to zero. To zero the unit, we put the transducer against a piece of metal of a known thickness, and what's a really cool thing about this design is the piece of metal you use for the calibration is the battery cap here. So all we need to do is put a drop of the coupling solution onto the cap, put the transducer on there, and hit here the PRB0 button. So, get our solution, put a little dob on the top, get our transducer, then once we're holding it down, press that button, and we're done. 10.5. Once you lift the transducer off, the final measurement that was read freezes on the display as well, which is a nice feature. Alright, let's take our solution and our little Checkline tool and see where we're at. So looking around, I think this little section here, you can see it's actually a little bit more rust coloured because I think the brush has gone over it's the deepest pitting. So let's try there first. Dob. Alright, so we're getting 3.8, 3.75 with a slight flicker between 5 and 6 bars. So I think we can be reasonably confident with that number, and that, as far as I can see, is the lowest point. So what I've done here, not particularly accurately or scientifically, but I've put 16 dobs here just in this little area, and I'm now going to go and measure